Hey guys, I'm making a video on conic sections. So what I need you to do is get either an index card or a piece of paper. You can cut the piece of paper so it's smaller if you want, but you don't have to. You can use an entire piece of paper. Just make sure that at least one of your edges is straight if you cut it. So we're going to start with a piece of paper, and you're going to put a dot on it, like a point, somewhere in the middle. It doesn't have to be exactly in the middle, just somewhere in there. And then you're also going to highlight the bottom edge of your paper, and that's the edge that you're going to want. You're going to want it to be straight. So make sure it's a straight edge. So if you cut it and it's not perfectly straight, don't use that one. So use a straight part of your paper. So that's what it looks like when it's highlighted. Okay, and then now what you're going to do is fold the bottom edge up to the point, like so. It doesn't have to be perfect. So it doesn't have to be perfectly straight across, but like kind of straight across. And then you're going to unfold. All right, so you made a crease. That crease should be halfway between the point and the bottom edge, right? So then we're going to do it again, but at a different angle. So we're going to fold that highlighted edge up to that point at a different angle, make another crease, and then unfold. And if you look, that crease is still halfway between the point and the edge. Okay, then do the other side. So fold it up at, it doesn't matter what angle, just make sure that it's the highlighted edge touching the point. So real quick, I'm just gonna highlight the other side of my paper. So you can see, I'm still just that highlighted edge to the point. And then I'm gonna do it at a slightly different angle. So I just did it at this angle. I'm gonna turn my paper a little bit, do it at this angle, make a crease. So now I have a bunch of creases, and you're gonna keep doing this at different angles. So keep highlighting, or keep folding the highlighted edge to your point and then unfolding it. Do it as many times as you can. So just fold, make a crease. Okay, so you should make like a bajillion creases if you can. In theory, there should be an infinite number of creases that you can make, but obviously we're not gonna do that. It'll take a bajillion years. Okay, so now you have the part of the paper that's completely smooth, and then you have the rest of the paper that's like foldy and probably soft because you folded it so much, and then you got like the hard piece of paper, right? So if you look, there should be a line that separates the soft piece of crumbly, wrinkled part, and then the flat, harder surface of your paper. If you take a pen or a pencil and you kind of outline that, you get this shape, okay? So what is this shape? It's a shape that we've studied before. It should be a parabola. Okay, so in chapter 10, we're going to study parabolas in a different way, in a way known as the conic sections way, because a parabola is a cross section of a cone. So if you take a cone, one second. Cone, pretend this is a cone. So if you take a cone and you slice it that way, you're going to get a parabola. You'll also get other shapes as well. So this is our parabola. This dot and this line, these are significant parts of our parabola. So the dot is called the focus, or like the focal point of the parabola, right? The parabola is kind of like centered around it. And that bottom line that we highlighted, so the highlighted part of our paper is representing what's called the directrix. Halfway between the focus and the directrix are all these points that created the parabola. And there's one very special point that you know called the vertex. So the vertex is right in between the focus and the directrix. It's one of the many points on the parabola, but specifically it's right underneath the focus. So going through the focus and the vertex, right, going right through it, that's your axis of symmetry. So your axis of symmetry, going right through those two. Now there's also this new chord. It goes from one side of your from one side of your parabola to the other side of the parabola. So it touches the two sides of the parabola, and specifically it goes through the focus. So that's the important part. It has to go through the focus. If it doesn't go through the focus, if it's say up here, it's a lot longer. Or if it's down here, it's a lot shorter. So this is a special chord that goes through the focus, and it is called the lattice rectum. Okay, so that's a piece that goes through the focus. It's parallel to your directrix. It's perpendicular to your axis of symmetry. Okay, now how are these all related? So we know that vertex form of our parabola is y equals a times x minus h squared plus k. And they're related with a. So the distance between the focus and the vertex, so how far away the focus is from the vertex, that's 1 over 4a. So if a is 1, then that means the focus is 1/4 of a unit away from the vertex. Okay. It also means that the vertex is 1/4 away from the directrix. Okay, so the directrix is 1/4 away from the vertex, and the vertex is 1/4 away from the focus if a is 1. If a is something else, let's say a is 1/2, so that would be 1 over 4 times 1/2. So 4 times 1/2 is 2, so that means this is 1/2. So that would mean that the vertex is 1/2 a unit away from the focus, and then 1/2 a unit away from the directrix. Okay, so where does the lattice rectum come in? The lattice rectum has a length of 1 over a. So if a is 1, this whole thing is 1 unit long, meaning from here to here is 1/2 a unit, and here to here is 1/2 a unit, so that the whole thing is 1 full unit. If a is 1/2, the lattice rectum would be 2 units long. 1 unit, 2 units. So that's why when a is 1/2 or anything less than 1, that makes the lattice rectum longer, which will make your parabola wider. If a is like 7, then that means that the lattice rectum is only 1/7 of a unit long, so it's going to get really, really skinny. Okay, so a is what controls the like the skinniness or the fatness of the parabola, and it also controls how far away your focus and directrix are from your vertex. So that tells us a lot. Now, what you'll do in chapter 10, you're going to do vertical parabolas, but you'll also do horizontal parabolas. So when parabolas are horizontal, they have a slightly different standard form or vertex form. You'll see it's going to be x equals instead of y equals. The y is the quadratic term, so it's squared. K is still representing the same thing, and h is still representing the same thing. So h is the x coordinate of your vertex, and k is the y coordinate of your vertex. In both equations, they represent the same thing. It's just that the equations are different. So real quick, for example, so let's say this is our equation. In this equation, our vertex is going to be at 1/5, and a is 1. So that means your lattice rectum is 1 unit long. Now, in my second equation, okay, my second equation looks different, but my vertex is still at 1/5, and a is still 1. So these are going to look like very similar parabolas, except the first one is a vertical parabola, meaning it opens upward. It can also open downward if a is negative, but a is positive. Okay, so this one's opening upward. This one is opening up to the right. Okay, and what tells us it's opening up to the right is because it says x equals instead of y equals. So if y is not squared, then that's going to be a vertical parabola. If x is not squared, it's going to be a horizontal parabola. And so you'll be graphing these all in chapter 10, along with circles, ellipses, and hyperbolas, which are also conic sections.